So in this video, we're going to be talking about the obtuse case. So if you have a SSA, so if you have a side-side angle, so that ambiguous law of sine case, then if you have an obtuse angle, so that means an angle that is bigger than 90 degrees, then you can follow these. You're probably going to end up with these two cases. So the first case is if your side is smaller than your other side, then you're not going to have a triangle. And let me just draw a picture of what that might look like. So let's say you're producing a triangle, and this here is an obtuse angle this time. And so I need to make it wider to accommodate. So this side's B, and this side is opposite of the A angle, so this must be little a. So this is basically saying that your A is smaller than B, but that wouldn't make sense because we know that obtuse angle should always produce the biggest side length. And if this is too short, it's not going to touch base with the other point of to complete the triangle. So that's why this can't happen and there would not be a triangle. Now, if you have the other case around where A is the longer piece, so A is bigger than your B, then you can have at least one triangle, but only one triangle. So obtuse is a little bit easier to handle because you either have no triangle or just one triangle. So we're gonna solve these two problems down below in example 3 here. So this first one, I have the angle and I have its side and I have another length, so I have to complete the triangle. So I always start off with finding that opposite angle that I'm missing, but I have the side for. So using law of sines, I start with putting the 8, the A on top, and sine of 120 on bottom, and set this proportional to B, which is 11 over sine of B, and I'm going to try to find sine of B, or B, the angle. So if I do cross multiplication, I can try to isolate the sine of B first. So 11 times sine of 120 degrees, and then I'm going to divide off the 8 to try to get sine of B by itself. And so if I pop this into the calculator, it looks like I get 1 point, I'm just going to add extra decimals just in case first. So about 1.191. And I already start to notice something fishy here. This can't be possible because sine can only be a value between -1 and 1, and this is over 1. So I already know this just can't work. This is not possible to get a triangle, so this is not possible. Also, when I look at these lengths here, this is very suspicious. A is smaller than B, right? 8 is smaller than 11, so A is too short, and this was an obtuse angle to begin with, so this is like that case 5 that we were mentioning about, so that's why that triangle is not possible, because this is that case 5 where your triangle is, the A here is too short, so it doesn't produce a triangle. All right, so let's make sure we're looking at our side lengths before we start. So this one here has an obtuse angle again, and it looks like A this time is bigger than B, so that's good. So I know I should be getting at least one triangle if this is the case. So let's go ahead and set this up. So I'd have 12 over sine of 120. So I'm just doing that same thing where I'm trying to find my angle B first. So I'll cross multiply. And so that would get me 12 sine of B, 11 sine of 120. I would have to divide off 12. And so this gives me sine of B. And then if I plug this into the calculator, I would get, let me round this to a few decimal places. So let's see, 7969. Is how much I get. And so this number does comply to the range for sine, so it is between -1 and +1, so this works. And so I'm going to take the inverse sine of this. So if I want to find B, I have to take the inverse sine of 0.7939. So I'm taking the inverse of this so I can find B, And this gives me, so plugging this in the calculator gives me 52.6 degrees. So I'll put 1 decimal place here. And that is going to be my B value. Now, the nice part is if you have a obtuse angle, you don't have to worry about having 2 triangles, because you wouldn't want like to subtract this from 180, because that would give you another obtuse angle, and you can't have 2 obtuse angles in a triangle. So that's why there's only 1 triangle here. So let me just draw the picture here. So you have this obtuse angle A with 120 degrees, and opposite is 12. B is right here, maybe that's 11. And the B angle we just found is 52.6 degrees. So if I want to find angle C, I can just take 180 and subtract it from both of these. And that would give me, so I'm going to really do that quick on the calculator. It gets me a really small angle, just 7.4 as my angle here. And then all I need to do is find this length C left. So I'm going to create another proportion. So I'm going to just take 12, do it in blue, 12 over sine of 120. So notice this is just the proportion for A, and I'm going to compare to the proportion for C. So sine of 7.4 degrees. And then I'll just do my cross multiplication. So this would be 12 sine of 7.40, C sine of 120. I would have to divide this over to cancel out this sine. So I have to divide the sine 120 over to the other side. And so C is going to be 12 times sine of 7.4 degrees divided by sine of 120, which gives me 1.8. So this is 1.8. Now, what I always like to do is double check. So I notice this is the smallest angle. This is also ends up being the smallest side. This side is the biggest angle. This is the biggest side. This is the middle, and so it was the middle side length. And that means that this is probably done correctly. All right, that's it for this video. If you want to try some extra problems, try some down below, and the answer key is provided to you on Canvas. Make sure you show your work to get full credit though. All right, bye guys.